Hi everyone. Welcome to another episode. Again, I'm lagging by two questions this time as well, but let's not waste any time and get on with the question. So the question here says, you're given an array nums, which has integer greater than one. So I guess he means that the count of the integers is one, more than one. And then you need to return an array output such that it's equal to the product of all elements except num of I. Okay, let's look at the input to understand the question more uh, better. So, okay, you're given one, two, three, four. So you have to give product of elements and accept the num of I. That means 2 threes are 6, 6 fours are 24. So except 1, we give the product as 24. Now here except 2, we are going to take product of all other elements, which is 1, 3 and 4, which is 12. Similarly, except 3, it's 1, 2 and 4, it's 8. And for 6 as well, it's 1, 2 and 3. So it's guaranteed that the product of elements of a prefix or suffix array fits in a 32-bit integer. Okay, so they have given us one more constraint, and you need to solve it without division and an O of n. Follow up, can you solve it with constant space complexity? The output array does not count as extra space for the purpose of space time. Okay, so he says we can't use division, obviously, because otherwise it would have been very easy, because I just do a product of 1 2 3 4 once, that is 24, and then I iterate over each element and just divide it with that value to get the output value. So we can't use division, and we need the time complexity to be often. Let's look at the problem through diagram. I'll type it here. It's 1 2 3 4. Okay. What could we do in, like, just not use division and you need O of n time complexity? I can use left array, and left array, I'm taking the product of all the elements to left of it. So in case of 1, obviously it will, I'm just taking it -1 because there is no element left of it. For 2, it's 1. For 3, it's 2 ones are 2. For 4, it's 6. Similarly, I take a right array which has sum to its right of it, so I'll start from 4. So 4, there's no element of right of 4, so I take -1. Then for 3, it's 4. For 2, it's 4 threes are 12. And then for 1, it's 24. Right now, what do? I think I have the left and right products. I just multiply both of them together, right? So in case of 1, because there is no element on the left, I just simply take 24 in this case. In case of 2, I multiply 12 into 1, which is 12. In case of 3, I just multiply 4 twos are 8, which is 8. And then in case of 4, there is no element right of it, so I don't take these two elements, which is 6. So this is our output array, right? So this is O of n time complexity, and we didn't use division. So that is the way we can solve it, by taking the left product of each element and right product of each element and just multiplying them together. But it says follow, can you do it with constant space time complexity? So in terms of complexity, I think the hint stays in here. He says that it fits a 32-bit integer, so why not use bitwise operation? So we know that bits, if we represent each integer in bits, we can use it. One good way would be to use implement division in bitwise, because the bitwise operations won't be you utilizing any division, right? Basically they are saying not to use division. So we can use bitwise division. uh, what does it, how do we approach that part? Let's look at it. Now let's say, for example, I just take a small example. Say, uh, basically division is nothing other than subtraction, right? So in this case, let's say my product is 24. Okay, hold on. Now I need the product at the value at element 1 without 2, so it should be 12. My answer should be 12 here. That means where is the other? That means 24 divided by 2 is 12. We need this value. So how do we do it in bitwise operation? So in bitwise operation, let's represent 24. 24 will be 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1. This is 24, and this is 24, and this is 2. 0 0 0 1 0, right? So we need, what we do is we bring in bitwise operation, we bring this bit to the most significant bit that is there for the number, which for the, basically this is the dividend, right? This is dividend and this is the divisor. So as long as the divisor is fitting into the remainder, that's what we try to do. So basically what I'm trying to do here is, this is 2 to the power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Now I'm basically trying to bring this bit, I'm gonna do a right shift on this bit till the time it's equal to this most significant bit of the dividend, and I take that value. So let's go over this example. It's a 24 and 2. So initially when I do a right shift of this bit, which is till here, and I reached here, so what is it? What is this basically? This is none other than 1 reaches here, which is 2 to the power of 4. 2 to the power 4 is 16. So we take 16, right, and we subtract it from this value. So we get 24 minus 16 would be 8, right? Now we do 8 divided by 2. Basically 8 is something like this, 3 and then 0 0. So we reach till this point, 0 1 2 3. Okay, which is 0 1 2 3. Sorry, my bad. We are gonna we okay we when we divide this, actually the loop will break before we reach the significant bit, which is because n has to stay greater than this. So 16 is 0. I think I'm missing something, the bits here, and then I right shift it till the point. Obviously I'm right shift it till the point it's here. Oh yeah, that's correct, because I will break out. So my basically when I'm right shifting, my loop will break out when my 2 gets here, because if I reach here, then it will be, it's not exactly basically dividing it or subtracting. So basically we need to stop at one significant level before this. So we'll stop here. So it's gonna give us 8, because this bit will be set. Now here in this case we stop when there is 8, so we subtract it, right? So now similarly it's 8 basically now, and we do an 8 divide by 2. So we stop at one significant level if 4 8, so that will be 4. So 8 plus 4, which will be 12. It's because we'll be taking all of all the values it takes to divide it. So I think it will be more clear when we see it in code. So let's try to write a method that divides integer in bitwise operation. So divide. I'm storing, this is my q is my quotient, right? Because we need a quotient and we know it will be completely divisible because it's going to be a factor in this product, because we are taking product of all the elements first, right? So basically I'm taking b equal to 1 and then I'm doing okay, and then I'm doing while n is equal to t, I do and I take a temp variable and then I do while and then we return the question. So in this case we take out say divide bitwise will be p common. Let's see. Okay. Okay. Okay, I think I need to take unsigned int for this purpose. Because we know it's gonna be unsigned. Keyword for it. So okay, unsigned int. So I guess if I do that, let's see. Okay. I think I'm stuck here. I guess I'm gonna do it. Oh, maybe with the left and right space complexity for now. if I find any other way, um, I'll try to do with that approach. So I left off. I need to take the same size as that size. Right, and left of 0 will be obviously -1, and the right of I'll take and then -1 will be -1 because there is no right of it, and then for here I'll start with 1. Oh wait, I'm doing something wrong. Should be nums of size. That's why I guess I was getting an error. Maybe the bitwise operation was right. Or maybe not. Okay, and then left of 0 is 1 and right of 1, and then I do a for loop size plus, and then I do left of I -1 star. Because we are trying to take the product of that, and then for right -2 greater than 0 minus do right of I is equal to right of okay, and then I do I plus 1 star and then for each of this I equal to 1 and -1 I do output of I is equal to left of I star right of I, and then output of 0 is equal to left of right of 0, and then output of I can check the diagram again. Right of 0 and left of n minus 1. Output of n minus 1. And I can scrap this off. I will try with the bitwise operation again, or maybe for the space there might be something else. The unknown type. So basically we are not using division operation, and so we are able to solve it in this, but we are not able to solve it in constant time complexity. I get a compile error. Why I'm getting this error here. Okay, it was P causing the problem. That's fine. So, what is wrong here? It's 12 8. Only the first and the last are causing the problem. I need to see. So, output. Your answer is 0 0. Left off versus. Oh, my bad. It should be. Um, Actually, it shouldn't be minus one. It should be this. So, okay, 086 is right, but sorry, the 0 is wrong. 1286 is right. So output of 0 is not right of 0. Right of 0 should be. Correct. Awesome. I guess it should pass. Awesome. Sorry guys, we didn't when you I was not able to solve it in constant space. I had to take two arrays instead of one. Mm. I'll give it another shot, but I hope this approach was clear and this was clean and easy approach. If you guys like this video, please subscribe to my channel and give me a thumbs up. Thanks everyone.